Hi everybody. Today we're going to talk about a radius intersecting a chord, and specifically we're going to talk when the radius intersects the chord at a right angle. Okay? So in this case, we have a radius here, we have a chord here, and it's going to intersect at this right angle right here. And then there's the right angle that we're talking about. Okay? So radius intersecting the chord at a right angle. Okay, so the property that we're going to talk about only applies if it's at a right angle. So it's really important that you make sure the radius is intersecting right here perpendicular to the chord. So it's if a radius intersects the chord at a right angle, then the radius bisects the chord. If a radius intersects the chord at a right angle, then the radius bisects the chord. Okay? So in other words, if AB is perpendicular to DC, then DE is congruent to EC. Okay? So if AB is perpendicular to DC, this is the symbol for perpendicular, then DE is congruent to EC. Okay? So then this piece is congruent to this piece. It cuts it exactly in half. I want to make sure that that's sort of highlighted there. DE and EC are congruent. They're the same. Okay? Alright. The other thing is that if a radius intersects a chord at a right angle, then the radius bisects the intercepted arc. If a radius intersects a chord at a right angle, then the radius bisects the intercepted arc. Okay? So here we are. We have a radius AB. It's perpendicular to chord DC. So what does it do? It bisects this intercepted arc that's intercepted by the chord. So from D all the way to C, the radius cuts it in half. So this piece is congruent to that piece. Okay? So if AB is perpendicular to DC, then arc DB is congruent to arc BC. Okay, so that makes this pretty simple to do. Essentially, we're just setting these two pieces equal to each other. We know that they're equal, they're congruent. Okay, their lengths are going to be equal. So, let's look at number one. It says, find DC. So it says, we've got AB, and it is perpendicular to DC. So this is a radius intersecting a chord at a right angle. So what do I know about these two lengths? I know that these two lengths are congruent. Okay? Therefore, we say 3x minus 4 equals x plus 22, and we go ahead and solve that. Okay? So we'll subtract x from both sides, and we'll add 4 to both sides. So 2x equals 26, so x equals 13. Now we have to be very careful about our answers, guys, because they don't always ask for x. Sometimes they ask you to find the length of the line, so pay attention to what they're asking you to find. In this case, they want to know the length of this whole line, okay? So you can do it in one of two different ways. So that's finding x. So then we'll say the length of DC. That's what this side is. So you can find part of it and then multiply it by 2, or you can just plug in x and add it all together. My preference, I like to put it into this part right here for x plus 22 and then multiply by 2 when I'm done. So x plus 22 equals 13 plus 22 because x and 13 are the same. 13 plus 22 is 35. This is half the line. So 35 times 2 equals 70. So DC is equal to 70. Okay? This looks like a C. It's really just a parentheses. Okay? Alright, so just make sure you're paying attention to what they're asking for. But essentially, this radius is going to cut this chord in half. So you just say this is equal to this. They're the same size because it cuts it in half. Alright, number 2. Number 2 says, find the length of the radius. So this is a common question that they like to ask, and it's going to involve knowing a little bit about right triangles. Okay? So it says the length of DC equals 60 meters. That's what it gives me. So all of DC is 60 meters. It also says that the radius is perpendicular to this chord. So what does that mean? Well, that means that this length right here is congruent to that length right there. They are the same length. So if the whole line is worth 60, how much is one worth? 30. Okay? So now I can figure out the length of the radius by drawing a right triangle. Okay? So if I draw a right triangle, I've got this line right here. This is also a radius. Do you see how it goes from the center of the circle to the edge of the circle? And then I've got this shorter line right here that doesn't quite make it all the way to the edge of the circle. That's worth 16. Okay? Yes, AB is a radius of the circle, but I'm only dealing with A to this middle point right here where they intersect the chord. So that is not the radius. The radius is not 16 because it's not all the way to the edge of the circle like A to D is. Okay? So let's draw this triangle down here so we can see it. We've got A, we've got D, and we've got this point here, which I don't know what it is, but how long is it from D to here? Well, from D to there, we said, was 30, and from A to this intersection is going to be 16, and this is a right angle, okay? So if I'm trying to find AD, which is a radius, I can call that R, because it's a radius. I'll put an R up there too. So we're trying to find this radius right here. So I'm just going to use the Pythagorean theorem. So it's A squared plus B squared equals C squared. Remember, A and B can be either number. So 16 squared plus 30 squared equals C squared. Whoops, R, right? Not C. And then just solve. So 16 squared is 256. 30 squared is 900. When I add those together, I get 1,156. So then I'm going to take the square root of both sides. And I get R is equal to 34. Okay? So if it asks you to find the radius and it gives you this little picture here, just remember that you can always draw a radius from any to any point on the edge of the circle. I could have drawn my radius over here if I wanted to, or I could have drawn it up here. But if I draw my radius up here, it's not really going to help me to figure out its length. So I'm going to use the parts of the picture that I have. So just knowing that this is also a radius. That's probably the hardest part of geometry, is that cleverness, like trying to figure out from where do I join something so that I can find a missing length. Okay. Thanks for watching and have a nice day.